Hi, this is Mike Hendrickson from Fluent and Velocity in San Jose. I'm here with Mike Strickland from Intel. Mike, how you doing?
I'm good, thank you.
So one of the themes we've heard, and we've heard it for 10 years, is about operations and DevOps and performance. How is Intel's FPGA program going to help people with getting better performance?
Yeah, so as you said, one of the themes here at the show is performance and flexibility and being able to move quickly, and the IT data center environment is moving quickly. The good news is FPGAs are programmable, so they're inherently flexible and adaptable. However, the challenge in the past has been the ease of use for these FPGAs. While they're widely deployed, it requires people with specialized programming knowledge, and for the average enterprise data center, it's been a little bit complicated for them to use these FPGAs. So Intel is taking the approach now of integrating these FPGAs underneath frameworks and APIs so that they're easier to use for the enterprise.
Well, how does a framework and an API make it easier for a developer to use your FPGAs? I mean, is there some magic? Are you hiding some of the complexity? What's going on there?
Well, let me go through an example. So for instance, Intel has been talking about a proof of concept we're developing to accelerate the shuffle phase of Hadoop or Spark, where you aggregate the results, by using better compression with the FPGA. And so Intel is always developing frameworks and APIs that are tuned for performance for Xeon instruction sets, and so there's a Spark framework that's out there. We can now integrate the FPGA underneath what would normally be a compression call to some software and hide the FPGA underneath it. So the software is unmodified, makes the same compression call. Instead, it goes to the FPGA. And one of the advantages now is at runtime, you can either run on a Xeon processor or you can run on the FPGA, so you have that flexibility. And as well, you have now from Intel an accelerator and Xeon processor with end-to-end virtualization and security. And then lastly, I would just say that, as well, it's an integrated solution from orchestration, so we're OpenStack compliant.
So is this going to make life easier or more complex for a data center? I mean, our FPGAs are intended to make things more performant, faster. Are they going to be scalable and resilient as well? I mean, is that going to make the data center people's life better?
Sure. So one well-known example right now is Microsoft, and Microsoft shared a lot of information about how they use an Intel FPGAs. So they've talked about accelerated machine learning, networking, different types of traffic. However, not everyone has the expertise that Microsoft has in terms of operating software and even FPGA knowledge. And so what we're delivering now is an approach that so completely hides the FPGA that your analytics program doesn't have to be changed at all. So whether you're running a Hadoop job or traditional SQL relational job, there's no change to that. So from the point of view of the programmer, they have no idea that an FPGA is there, except for things running faster, of course.
So if you're making FPGA acceleration more attainable for your data centers, you're making life quicker, and we're going to be able to start to crunch more data? Is that, I mean, the panacea here is that when your machine learning is going to be crunching big amounts of data, is this FPGA approach going to make things much better?
Yes, absolutely. And so it's a very competitive environment in cloud hosting. And of course, enterprise data centers have to be a little bit more efficient as well to keep up with that. And so to give you some examples, we have one partner, Swarm64, that can take a traditional relational database and accelerate it over 5 times for real-time data analytics. And so the FPGA there is doing some compression into Xeon memory to fit more data, or they're compressing the storage so you get more bandwidth and you read off the storage, or they're maintaining index lookups that are more efficient. So now with the same server, you plug in an Intel-branded PCI Express card, and things run 5 times faster to be able to do, for instance, 1 million updates and queries per second. There are other examples as well. We have another partner who does key value store, a NoSQL example, and the FPGA completely offloads the networking. So a request comes in through an Ethernet interface. The FPGA decodes the packet, does a quick lookup, because FPGAs are good at hashing, and returns a value 3 times faster than a traditional server.
And is this going to make life easier or more complex? I mean, is it going to be simple to design for deploying your large data sets or making sense of the large data sets on an FPGA? Or are you guys making that through your APIs and your frameworks more attainable for the average developer? Or,
yeah.
yeah.
So one of the beauties of fitting into these existing APIs is no software needs to change. So to give you, go back to the example of Swarm64, there's no change to your application software or the database schema. Everything stays the way it was before, but it runs faster. So I think it will actually make things easier, because if you have predictable latency and lower response times, that always makes for a better end user environment.
And where do you see developers deploying this most? Is it for edge applications, or is it for large data sets in a large enterprise crunching, customer records? Or where do you see this most useful?
Yeah. So today at the show, we're focusing mostly on the traditional data center. So these servers that are running SQL or Hadoop or NoSQL, key value store, or even traditional relational databases. But you talked a bit about the edge, and it's not the focus of what I'm talking about today, but certainly FPGAs are good on the edge. So for instance, on video analytics, doing some pre-filtering, identification of what the cameras are sending in. So that's maybe another interview with you to talk about the Internet of Things and ways in which FPGAs can accelerate those workloads as well.
Excellent. So, Mike, if you were to fast forward 12 months from now, where would you like to see FPGAs and Intel in the market? Is it more deployment, more use, APIs richer? What would you like to see happening in the next 12 months?
So 12 months from now, I'd like to come back to this show and be able to talk about end-user deployments. We have some partners running some of the traditional benchmarks like TPC-DS, and I think we'll see some pretty impressive results. And so I hope to come back a year from now and have end-user examples, some really nice benchmarks, and some case studies that are very compelling.
Excellent. We look forward to that.
Pleasure.
Thank you.
Thank you.